Hi, I'm Kruno. Thanks for watching EPLAN Essentials. What is EPLAN? What can EPLAN do for you and why you should consider EPLAN? These questions we will cover in a new format on this channel called EPLAN Essentials Expert Edge. Alright, as you know, on the EPLAN Essentials channel, you receive complex industrial topics presented in an easy, digestible way. And when it comes to the question, what is EPLAN, there is one person who can explain it even better than I can. And I'm very pleased and honored that he is the guest on the first ever EPLAN Essentials Expert Edge. It's Sean Mulherrin, 30 years veteran of EPLAN. So Sean, how would you go around the question, what is EPLAN?
Hi, Kruno. First of all, thanks for having me online, and it's a pleasure to do this Expert Edge session with you, and I'm looking forward to many more. I see that you got some really cool content in the pipeline. So, well, the first question of the day is, what is EPLAN, right? And I've been asking myself the same thing, even though I've been working for EPLAN for close to 30 years now. I've been wondering, how can you take EPLAN and explain it in a simple way? Because over the last 40 years of existence of EPLAN, which was founded in 1984, EPLAN has developed many different functionalities. We've had different versions of EPLAN, and we've always kept on building on top of what we've already had. So we are flying at a really high level of automation and controls design and things like that. And sometimes it's always good to reflect as to, well, what is the basis for EPLAN? Why is EPLAN there, and why was EPLAN developed in the first place? And I kind of put that question to myself and try to figure out a way of explaining it. And I think I found a relatively decent approach that I'd like to give a presentation on.
Yes, please share your screen and your wisdom with us.
Can you see my screen?
Yes, sir.
So I'm going to use the example of a conveyor system to kind of talk about the engineering process, automation controls design, control cabinet design. And these are all topics that you hear on a regular basis in our world of work or in our line of work. But what does this mean for EPLAN in real terms from a pragmatic perspective? And let's try and break this aspect down and give a clearer understanding to our audience of what is EPLAN. I would like to build a conveyor system. So to build a conveyor system, there are various different engineering phases that need to be gone through and need to be developed to put this together. And the first one is the mechanical design. Mechanical design is looking at the conveyor system, understanding what does it need to do, how are we going to build it, what materials are we going to use, what is it going to look like, how wide is it going to be, how long is it going to be. All of those different aspects are going to be considered in the mechanical design environment. And to design that machine in a mechanical aspect, users are going to rely on tools such as Autodesk Inventor, SolidWorks, Siemens NX, PTC Creo, or if you're working in the cloud, maybe even Onshape. And they're going to use these tools to lay out the mechanical foundations of the system. They're going to design the frame, they're going to put all the sheet metal, they're going to identify all the nuts and bolts, they're going to identify where are the weldings, they're going to put all of the gear systems together to create the rotation and the pivotal points on the machine. And all of that is going to take some time, and they're going to use these 3D tools to design these systems in 3D. Now, once I've created my mechanical design, what is this going to look like in the real world? Well, I'm going to build the machine, it's going to stand there, and is it going to work?
Probably not.
Exactly. From a mechanical perspective, it's really not going to work, is it? It's just going to collect dust. And the reason is because from a mechanical perspective, we don't have movement. We created the aspects where we need movement with the gears and all of the different aspects, but we need to create movement. And to create movement in the controls and automation world, we need an actuator. What is the most famous actuator that people know about, Kruno?
It will be a motor.
That is correct. And a motor is typically run on electricity, right? It's not necessarily a steam motor. It's going to be more of an electric motor. Steam motor was the basis of automation back in the days, but now we're using electric motors. So I identified an electrical motor that's going to power my conveyor, and I bolted it onto the conveyor. I hooked it up to the gear system. So now my motor is connected to my mechanical system, and now it should be able to work, right?
Almost. We need one little thing, and that's called electricity, right?
That is correct, Kruno. Unfortunately, an electric motor does not work if it does not have any electricity. And as the word says, electric motor, we need some electric power to make it run. And this is where EPLAN comes into play. I call EPLAN kind of the electrification of the control system. And this meaning that all of our actuators and all of our sensors on the machine need to have some kind of electrical power connected to them or electrical signals, and these need to be identified. In the case of the motor, we need to provide electrical power and the controls to this particular motor. So let's bring in our three-phase power. I brought in L1, L2, and L3 from outside, and I connected it to my motor. Now what's happening, Kruno?
The motor is running and running and running and running.
So it never stops, right? It's connected, everything's working, the motor is running, but it never stops. Now, on our conveyor system, we really do need it to stop, because if I put a can of Coke on one end, it'll fly off the other end and it'll never stop. So it'll defeat the purpose of our conveyor system. So in this particular case, we need something to start and stop the motor. And we going to use a device called a contactor. The contactor allows you to open and close these three-phase circuits and allows you to start and stop the motor. But on the contactor, there's a button that you can push to start and stop it, and it's pretty tedious to reach. So in this case, we're just going to add something a bit easier, which is a push button. I'm going to click on the start push button to start the motor. I'm going to click on the stop button to stop the motor. And this is going to interact with the contactor to open and close these circuits and control my motor. So this is really the basic foundation of control systems, where you use devices such as push buttons to actually control the movement and the working of a particular piece of equipment or machine. Now I got one piece missing, Kruno. What is that?
It's a protection for the motor. So what happens if there is a motor overload or overcurrent? You
Exactly.
need to protect it.
The motor is a very expensive piece of equipment, so we need to make sure that it doesn't blow up as soon as we got too much voltage or too much current coming in our system. So we need to protect it, and that's kind of the last little final piece of the puzzle. It's adding a protection device to make sure that that motor doesn't break or explode, in the sense of, they really actually do explode if you put too much current in them. So it's quite scary. But in this case, we've got our circuit diagram, and now we are able to run our machine and also control the machine and protect the equipment on the machine. So again, what does this mean for EPLAN? Well, EPLAN is in the process of designing all of these systems. And in EPLAN, you will see these types of diagrams. Now you don't see the picture of the motor, you don't see the picture of the contactor, you see symbols. And these symbols are standardized based on norms. In the IEC world, you'll see these symbols standardized here. For example, QA1 is your contactor, FC2 is your protection device, and MA2 is your motor. So these are real devices in the real world, but in the schematic perspective, these are connected together, creating these types of design. And using EPLAN, you can create these designs incredibly fast in a very efficient way, making sure that you don't have any errors in connecting everything together. You can automatically generate your bill of materials to order all of the components, and you can also generate all of the documentation needed to connect these components and to build this system in real life around your machine or your application. So again, EPLAN, and specifically in this case, EPLAN Electric P8, is the tool to help you create your schematics efficiently, quickly, and error-free. Now, we looked at a very simplistic approach to controlling our motor. Let's take the next step in automation is automating the whole process. And this is done with a PLC. Using a PLC, which is a computer, you will be able to automatically start and stop this motor based on specific feedback from the machine or from the user, either through a direct human-machine interface or also through push buttons, identifying when the motor needs to start, when it needs to stop. And that PLC can be programmed by a software engineer that is going to run that entire machine. And now what does the schematics look like? They look a little different. Now, instead of having hardware components, we have a bit of software components, such as our PLC I/O, connecting our push buttons, again, to the PLC, and at the same time controlling that conveyor motor. So there you have it. In terms of controls design, EPLAN is the tool to help you create and design your schematics efficiently and quickly, putting control systems together very efficiently. Now, Kruno, in North America, I think they don't design it quite the same way as in the IEC standards, correct?
Right, that will be my next question. How are we looking with the NFPA standard in EPLAN?
Well, if you work with EPLAN, you can also design your control circuits for the North American market. And we provide you with symbol libraries for ANSI, IEEE, NFPA, or UL standards. Also, the naming conventions can be automated in EPLAN. You can generate your cross-references automatically. You can do all of your wire numbering automatically. And these are all tasks that EPLAN can help you to do quickly and efficiently. And at the end of the day, also generating an automatic bill of materials and providing the manufacturing documentation for your control panel. So a machine doesn't just have one motor. The example that we took with that conveyor and that single motor is quite exceptional because a typical machine would have multiple different motors, would have anything between 10 and 1,000 motors, depending on how big the machine is. But on a regular basis, you'll definitely have hundreds of different motors, you'll have hundreds of sensors, you'll have hundreds of different pages of documentation. And to be able to handle all of this design, all of this information, you need a very sophisticated and powerful tool. And this is where EPLAN Electric P8 comes to your help. EPLAN Electric P8 can handle thousands and thousands of drawings of documentation for your controls design and can also help you put these documentation pages quickly and efficiently inside a single environment. So there you have it. EPLAN Electric P8 can help you design your schematics for your control systems incredibly quickly and efficiently. So now that we have our motor on the conveyor system, where does the contactor and where do the protection devices go?
They're placed in the enclosure.
Exactly. So control cabinets are typically the environment or the device or the box, to say, that where all of your electrical equipment is going to be stored. And this is to stop it from being accessible by normal users and getting electrocuted. So the control cabinet, you're going to lay out all of your control system. You're going to place all of your devices and you're going to wire them all up. And to design these control cabinets, traditionally, in any type of CAD application, users will be doing a 2D layout. But why do 2D when you can do it quicker and faster in 3D? And that's the main message of EPLAN Essentials, right, Kruno?
Exactly, right.
It's showing how 3D can be really, really easy to design and lay out your control cabinets. And following steps in the EPLAN Essentials of Kruno is the EPLAN Pro Panel, and that is the tool to help you identify the control cabinets and also lay out all of the components that you've designed in EPLAN Electric P8 and place them inside of a control cabinet. In this case, Pro Panel, you can download a mounting panel or a control cabinet from Rital, for example, from the data portal. And once you have your 3D model of that control cabinet, you can easily lay out your cable ducts, you can easily lay out your DIN rails, you can place your components on your DIN rails or on your door or on your side panel, and then you can easily wire everything together. And if you follow EPLAN Essentials by Kruno, you will see that you can have multiple different features and functions to help you quickly and easily lay out those control cabinets in 3D. So there you have it, another solution of EPLAN, which is EPLAN Pro Panel, to help you fast and easy layout of components in 3D, to do collision check. What is one of the aspects that I notice a lot of people always forget?
Probably now you're saying collision check, right?
Yes, collision check, but specifically on the devices.
Maybe mounting clearance.
Absolutely.
Of the
Exactly. The
devices.
mounting clearances, where do you find them? You find them in a PDF on page 3 or 4, and it's like, okay, make sure you leave 5 inches above the device and 5 inches below the device. And I know that most of the people building cabinets, they always forget to look at those values, and they put devices too close to each other. So now using EPLAN Pro Panel, you can visualize those mounting clearances in 3D, and you can make sure that you are leaving enough space above, below, and in front of the device so that you have enough airflow and the devices don't overheat. Additionally, you need to capture all of your drilling information to make sure that you can drill all the holes in the right spots and connect all of your components or attach your components to the backplate or to the door. You also can now do all of your wire routing in 3D. EPLAN Electric P8 knows how the components are connected to each other. Now you can easily take that information and route it because now you have the physical position of the components. You can calculate the length of all of the wires inside of your control cabinet. And of course, you can calculate the length of your DIN rails and your wire ducts based on the space that you have inside of the control cabinet. The last step in the automation process is building those enclosures, right? You have to be efficient in putting those control cabinets together. So in this case, what you're going to do is you're going to take the information from EPLAN Pro Panel and you're going to export it to various different production machinery. And here with Rittal automation systems, we provide machines like the Perforex. The Perforex is a machine that can automatically drill, cut, and tap holes on various different surfaces, such as the door or the backplate or the side panels. So you have that information already in Pro Panel. All you need to do is download the information onto that console that you see right next to the Perforex machine. You can lock in the surface that you want to drill, in this case, the door, for example. You can click on a button and then you can walk away. And the machine will automatically do all of the cutouts and the drilling and the tapping for that particular surface. That way you don't have to manually do that and spend a lot of time trying to manually modify those types of surfaces. So using those efficient machines, you can really enhance your cabinet building process. What is another task that takes a long time in panel building, Kruno?
It's the wire fabrication,
Absolutely.
wire installation.
Yes, in any given cabinet, you have hundreds and hundreds of different wires, and you have to make sure that you cut each one of those wires to the right length. You make sure you have to write the right label, and also you have to put the various different ferrules at the end of those wires. Well, now that you have EPLAN Pro Panel, and based off of Electric P8, you have the connection of the wires, you know how long those wires are, why not extract that information from Pro Panel and send it to the Rittal WT, for example? What does WT stand for?
Wire terminal.
So that is one of the latest machines from Rittal, which allows you to pull up to 36 different types of wires from, what is it, 0.5 to
6 square millimeter, or
6
in
square millimeter.
AWG from 20 to 10.
Brilliant. So you have all of these spools of wires just waiting to be used, and then you just download all of the wire list and wire information from Pro Panel, you send it to the WT, and the Rittal WT can automatically pull the right wires to the right length. They can crimp the wires, put the ferrules on there, they can label it, and there you have your automated wire fabrication for your control panel. So now all the user needs to do is take those wires from the WT and then connect them up into the control panel, making again a huge step in efficiency in putting those control cabinets together. So with this slide, it kind of sums up a little bit the what is EPLAN and why is EPLAN. So at the end of the day, you want to design your control system as efficiently as possible, as quickly as possible, and with barely any errors to enhance the quality of your product. And that's exactly where EPLAN Electric P8 will help you put the schematics together, and EPLAN Pro Panel will help you to lay out your control cabinet and provide data and the information for manufacturing your control cabinets. What do you think, Kruno? Was that understandable?
I hope so. We will let the viewers judge if this was simple enough, or otherwise we will have another iteration of this. But I think you summarized it very, very well. So there we have it. That's a wrap for today's session. Sean, it was a pleasure that you joined us on the very first EPLAN Essentials Expert Edge. For everybody, I'll blend in now Sean's YouTube channel, so please make sure to leave also there a like and subscribe to his channel. If you want him again on the Expert Edge, write it down in the comments. Sean, one last time, thank you for joining us. Until the next time, all the best.
My pleasure. It was a lot of fun and looking forward to many more.